Okay, so for lecture 6 in the Steel Bridges Concept Delivery, brought to you by the Short Span Steel Bridge Alliance, today we continue with that series of 6 lectures. And of course, just a review for the last time, the education packet is divided into those 6 lectures. Now, last time we looked at applications in accelerated bridge construction, an important way we build bridges today. Today we're going to go through lecture 6. Lecture 5 looked at applications in accelerated bridge construction. Some of those case studies we discussed are typical design bid build projects, or they are design build projects that use modular units and construction techniques to greatly decrease the construction time and the disruption to the public. Others were from bridge manufacturing firms that will design and deliver a bridge that can be installed quickly for accelerated bridge construction. ABC has become an important part of the bridge industry in that it reduces on-site construction time and disruption to the public. In lecture 6 here, we will look at a showcase of bridge case studies that these manufacturing firms can design, build, and deliver to the bridge site. Bridge manufacturing firms use experience and economies of scale to produce high-quality, beautiful, functional, and economical bridges for owners across the country. Many of the examples we will look at would also qualify as accelerated bridge construction projects, as we will see here in the case studies. So if I was asked, I would call today's webinar, hey, let's look at some cool steel bridge projects. It is meant to be a fun showcase of bridges that are available to us as owners and engineers from our steel bridge manufacturing industry. We will look at case studies from manufacturing firms that are members of the Short Span Steel Bridge Alliance. You may get more information about any of the firms through an internet search for sure, or from the Alliance website, shortspansteelbridges.org. In lectures 1 through 5, we have seen that steel bridges meet owners and the public's desire for economy, aesthetics, performance, and accelerated construction. Here in lecture 6, several bridge projects from prefabricated bridge manufacturers will be highlighted to demonstrate the merit of different types of manufactured steel bridge solutions. But first, a little reminder about the Short Span Steel Bridge Alliance. The Short Span Steel Bridge Alliance is a group of bridge and buried soil structure industry leaders who have joined together to provide educational information on the design and construction of short span steel bridges and installations up to 140 feet in length. The manufacturing firms are one type of member from that Short Span Steel Bridge Alliance group of stakeholders. The Alliance is involved with all aspects of simple span steel bridge design and construction, including outreach and education. An example of that is this webinar series. Resources on all aspects of steel bridges, sample case studies, the simple design tool eSpan 140, which allows you to get a design for a steel bridge in a matter of minutes, a technology center for owner and engineer questions, prefabricated bridge manufacturer solutions from Alliance members, and innovative and ABC bridge solutions to meet bridge needs. Today's webinar is a showcase of prefabricated bridges from the Alliance manufacturing firms. Designers can contact member manufacturer firms through eSpan 140 and explore the convenience, aesthetics, and economy of a prefabricated steel bridge. In the context of Lecture 6, prefabricated bridges are structures that are designed and fabricated by manufacturing firms and delivered to the site ready for erection. Some people call them pre-engineered bridges, but that is not entirely true since each bridge is individually designed and fabricated for the particular site and load characteristics. Most of the examples we will look at and most of the prefabricated bridges from manufacturers are also applicable for accelerated bridge construction. They are built into components, modules, and assemblies in a quality-controlled shop, shipped to the bridge site, and erected. This results in time savings for construction, cost savings, increased site safety, and the pieces will fit together really nicely because of the quality shop fabrication. However, another way to think of them is that they are a, quote, bridge in a box, in that the manufacturer has worked out all the design and all the details. They send it to the site, and the owner gets an aesthetically pleasing bridge without having the inconvenience of going through a typical design, bid, build process. Now for the showcase of bridges. Whoops, sorry. Some of what we will see will come across as marketing, as we mention names of the manufacturers and their products and view some of the videos. And of course, this is marketing also. But we are looking at these manufacturer bridges as options and possibilities for the owner or the engineer when considering what bridge should be selected to meet a bridge need. So we will start with what's called the Bouquet Street Bridge in Gibson, Louisiana. Now, I don't know if I said that name right, but that's how I'm going to say it. So the Bouquet Street Bridge replaced a 5-span concrete deck bridge supported on piles that was constructed in 1962. The prefabricated panel beam bridge replacement was 90 feet long with two 12-foot travel lanes. Acro, out of Parsippany, New Jersey, fabricates standard 6-foot wide panels that are placed side by side for variable width bridges. For the Bouquet Street Bridge, the panels were shipped to the site and Gray Contracting erected the bridge. The standard bridges are fabricated for quick installation with minimal labor and no field welding, no field cutting, or field fabrication. The bridge modules are fabricated with pairs of girders. Here with a steel orthotropic deck that had a factory-applied epoxy aggregate non-skid surface. All of the steel was galvanized for long-term protection. The modules were shipped to the site and set on the supports, and the orthotropic decks were simply bolted together for quick installation and no concrete curing time. The guardrails were then bolted to the exterior girder. The Acro prefabricated panel bridges provide a simple design, quick installation, a long-lasting life expectancy while meeting and even exceeding AASHTO load and design requirements. The Bouquet Street Bridge shown here used an orthotropic deck and steel guardrails, but the standard panel design can also use timber decking or a cast-in-place concrete deck and concrete jersey-type barriers. Prefabricated modules are built in the shop, shipped to the site, and simply connected together for a good-looking quality bridge. A simple concept combined with quality fabrication and practical erection planning, resulting in a great bridge product. Now, a fairly new concept for multi-bridge replacement plans is using public-private partnerships and bridge bundling programs as we discussed in Lecture 1. Recently, the Pennsylvania Department of Transportation Rapid Bridge Replacement Project involved the design, construction, and maintenance of nearly 600 bridges. This folded steel plate girder system from CDR Bridge Systems out of Pittsburgh was used on 7 of the accelerated bridge construction projects. In each case, with the folded steel plate girder, construction was completed with closures of only 30 to 35 days. This example, the JV70 bridge, is one of those that was constructed by Walsh Construction. The modular system installed with ABC saved time and inconvenience to the public. The units are fabricated in the controlled conditions of the shop. pre-topped with a concrete deck, here from A.C. Miller, shipped to the site and placed on the abutments. Folded steel plate girder bridges utilize cold bent steel plates to form an innovative girder shape that provides strength with lighter weight. Concrete deck panels are precast and attached to the girders to form composite units that can be shipped and erected easily and quickly. Instead of a more expensive ultra-high performance concrete deck joint like we've seen in the past, a simpler and wider high-strength concrete closure pour connects the deck panels to complete the superstructure system. The erection of the two-lane bridges with 4 folded steel plate girder units each was completed in 1/2 of a work shift on all 7 of the bridges furnished by CDR for the PennDOC bundled project. So what we're going to look at now is a video of these things going in. It is a marketing video from CDR, but it does show the folded plate system and the ease of erection. Pretty cool system, and I hope you could hear the sound. I'm assuming you could. So another form of the economical bent plate tub girder is the press brake tub girder. In lecture 5, we saw a press brake tub girder bridge with a 2.5-inch sandwich plate steel deck that gave it a very low profile. We also saw where the press brake tub girder can use girders pre-decked or with precast deck panels. This bridge in Mercer County, Pennsylvania, was designed by Construct out of Wyoming, Michigan, and fabricated by Valmont Structures out of Omaha, Nebraska. The bridge was built by Jet Excavating. So when they were going to replace this bridge, it was determined that there was a total weight limit for the existing abutments, and the lightweight press brake tub girder bridge met the load limits for the existing abutments. So no new abutments were required, and they could use those existing abutments for the new bridge. The Construct system utilizes 2 methods of installation: pre-decked modular units and field assembly. The pre-decked method is where the modular units delivered to the site already have the concrete deck on the girder units. The field assembly method delivers the cambered, galvanized, press brake form steel tub girders to the project site separately from the precast deck panels for the site assembly. Due to constraints on this project site and the equipment lifting capabilities of the contractor, it was determined the most efficient method of installation was for the new superstructure would be using the field assembly method, putting on full width precast concrete decks with grouted shear stud pockets for composite action with the tubs. The galvanized press brake form steel tub girders were delivered to the construction site and installed on the existing concrete abutments. 8 precast deck panels were delivered to the project site and installed on the new press brake form steel tub girders in one day. Then, over the next week, the shear stud pockets in the precast concrete deck panels and the transverse deck joints between the precast concrete deck panels were filled with high-strength polymer concrete. The concrete curbs were then cast and the steel guide rails were installed on top of the concrete curbs. This video shows the erection of the modular press brake tub girder units.
Construct utilizes components of precast concrete and galvanized steel to deliver a highly durable and cost-effective option for building new bridges or replacing old ones. Construct bridges can be designed with precast foundations and include a precast concrete bridge deck to completely eliminate the need for concrete forming, finishing, and curing in the field. The strength and durability of the bridge system continues with cold bent steel tub girders, which have been researched and tested by both Michigan State and West Virginia universities. These highly efficient girders meet all AASHTO LRFD requirements and offer an unmatched shallow superstructure depth for crossings in hydraulically sensitive areas. All girders are hot-dip galvanized, minimizing corrosion and further extending service life, ultimately providing over 60 years of maintenance-free protects the prefabricated bridge units are delivered. The Construct system allows bridge elements to arrive fully assembled with the driving surface already installed, or be shipped in pieces for a contractor or county agency to assemble themselves. Upon placement of these bridge segments, individual units are secured together by an ultra-high-performance concrete connection. Finally, sidewalls are formed and poured on site, and guardrails are attached. The final approaches are then completed, allowing the new bridge to be put into service and the road opened.
So as you could tell, there was a couple jinks and jitters in that video, because what I did was I took their 6-minute marketing video and edited it down to, I forget what this one was, a little bit over a minute, so that we could just see the important parts of this tub girder being installed. Next, we will look at a prefabricated modular beam bridge, which is a common erection technique from our bridge manufacturing firms. 2 beam elements are fabricated in the controlled conditions of the shop, shipped to the site, placed on the abutments, and connected together. This project is located in southern Indiana, about 5 miles outside of the town of Borden. The existing bridge was a narrow, deteriorating, 2-span bridge with a total structured length of 35 feet. The bridge was replaced in preparation for a large roadway widening project. A 36-foot 8-inch simple span prefabricated modular rolled girder superstructure was selected for the replacement, which of course means that they could remove that center pier. The bridge modules were prefabricated by Contact Engineered Solutions out of Westchester, Ohio, and the contractor was Civilcon. The new bridge was built with 3 modular sections that were shipped on 1 truck to the site. The modular sections consisted of 2 weathering steel rolled beams with a pre-attached corrugated metal deck. Bolted diaphragms connected the beam pair modules after they were set on the abutments. The concrete deck was cast in place and a galvanized steel railing finished the bridge. Again, this video shows the erection of the modular steel units. Oops. The superstructure package was designed and built so the local county crew bridge crew could install the bridge. Within 6 hours of delivery, the superstructure modules were installed and ready for deck reinforcement and concrete. Now we're going to look at one of those structural plate buried steel bridges. The Montgomery County Department of Transportation began construction of an extension of Century Boulevard in Germantown, Maryland. The extension crosses a tributary of Little Seneca Creek. The structure is 41-foot, 4-inch span, low-profile steel structural plate buried steel bridge with an 11-foot, 9-inch vertical clearance. The steel corrugated arch includes continuous longitudinal stiffeners, ring beams for reinforcing ribs, concrete headwalls to support the severe skews, and 14-foot wide concrete footers on each side of the arch. Lane Enterprises out of Camp Hill, Pennsylvania, designed and fabricated the buried steel bridge, and Francis O'Day built the structure. The Century Boulevard Bridge is a wide structure. In addition to 4 lanes of highway traffic, the 130-foot right-of-way accommodates a pedestrian walkway, a bikeway, and future transit ways that will facilitate a 15-mile extension of the Shady Grove Metro line. With 4 foot of cover on one side and 12 foot on the other, the structural plate arch culvert is designed to safely withstand highway truck loading and design railway loads for the metro tracks. The arches are shipped to the site in stacks of curved plates, bolted together to produce the arch, and lifted into place with light construction equipment, as we saw in Lecture 5. Without the shipment limitations associated with large conventional corrugated pipe, and because of the increased thicknesses and stiffer corrugations in the plates, steel structural plate is a viable alternative for significant bridge crossings. This is a steel structural plate system, but buried steel bridges can also be produced out of aluminum. A buried steel bridge is lighter weight, flexible, and able to handle anticipated settlement better than conventional bridges. With the lightweight structure, foundations are usually also smaller and less expensive. Because of the arch, shorter spans are required to achieve vertical clearance requirements. And there is a continuous road surface with no bridge deck or joints to maintain. So here's another example of a modular rolled beam bridge. The existing Swamp Creek Bridge, located in Sweetgrass County, Montana, suffered from high water events and scouring issues at the foundations. Gas tax funds were available and used to replace this, what they thought was the second worst rated bridge in the county. So 8 foot wide by 65 foot long twin beam modules were fabricated by True North Steel out of West Fargo, North Dakota, and the bridge was constructed by the local county crew. The modules had a pre-installed guardrail and corrugated metal deck for a gravel roadway. This bridge also used accelerated bridge construction abutments. True North's prefabricated steel box called the Supersill abutment and ABC abutment were shipped to the site and installed prior to delivery of the bridge modules. Starting in the morning, the local county crew and a crane set the 3 8-foot by 65-foot bridge modules by lunchtime that day. This video shows the construction of the Sweetgrass Bridge.
Swamp Creek Bridge for Sweetgrass County. It's a 24-foot wide by 65-foot span, pre-engineered modular steel bridge designed and fabricated by True North Steel. This particular job utilized the Supersill abutment system, which is a steel box form that consists of structural elements, and once set and installed, is filled with concrete. The supersill abutment is typically utilized in situations where the soils are conducive for a perch style abutment or a spread footing. Modular steel bridges are simple to install based on showing up in component form and simply bolting adjacent modules together to achieve your width and length, and utilize a steel back wall to protect each end of the bridge and provides a decent place to build your road approaches. Turnor's steel modular bridges seamlessly tie together the most important aspects of bridges, including aesthetics, cost, and installation time. Our durable, prefabricated, high-quality modular designs are low cost and can meet AASHTO, state, and local bridge design requirements. We ship them prefabricated directly to the projects so they easily can be assembled and installed by contractors or county crews, resulting in minimal road closure time.
Okay, so True North's bridge package was selected based on economics and the simplicity of the prefabricated modular design that could be placed on the abutments and bolted together. With the gravel riding surface on the corrugated steel deck, the bridge was open to traffic within a day and a half from when the first prefabricated bridge module was set. Now, several of the manufacturing firms have standardized truss designs that they prefabricate, package, and deliver to a bridge site. After Hurricane Maria in Puerto Rico, many crucial bridges were washed away and whole communities were isolated from civilization. U.S. Bridge has several standard prefabricated bridge designs, and they shipped 5 of their Liberty bridges over a 6-week period, amounting to 800 metric tons of steel for over 950 foot of bridge length. This bridge is the Morovis Liberty Bridge, engineered and fabricated by U.S. Bridge and erected by Del Val Group. The Liberty Bridge can be shipped as modules in containers, quickly assembled and erected, and can be used as a quality permanent bridge as they were in Puerto Rico. This particular bridge, out of the 5 sent, was a 24-foot wide, 3-span continuous truss with spans of 106 feet, 98 feet, and 160 feet, weighing 318 tons and shipped in 17 containers. The steel was galvanized for longevity and low maintenance. The bridge won the Engineering News Record Southeast Best Project Award in 2018. This is a short video, but it shows the erection of a 3-span prefabricated truss bridge. The truss parts and modules were shipped in containers to the site, sub-assemblies bolted together and lifted into place, and then a riding surface installed. The Morovis Liberty Bridge was constructed in 18 days. All 5 of the U.S. bridges sent to Puerto Rico were completed in 6 weeks. A local resident stated, "What helped us most was the construction of the metal bridge. Our manufacturing firms, with their innovative prefabricated bridge systems, can meet any bridge need and deliver bridge projects for owners." For our last manufacturer bridge case study, we will again look at a modular rolled beam bridge, one that is a little larger in size than the others we have seen. Many of the manufacturers produce standard modular bridges, and these bridges are being built all across the country due to economy, quality, and ease and speed of construction. The Sevier River Bridge, located approximately 2.5 miles east of Axtell, Utah, is a critical thoroughfare for the numerous farmers and ranchers in central Utah. The existing 1935 built bridge was structurally and functionally deficient and could no longer handle the load safely. The new 75-foot long bridge was built with modular rolled beam units using accelerated bridge construction techniques. The bridge modules were designed and prefabricated by Wheeler Bridge out of Minneapolis, Minnesota, and the contractor was Gerber Construction. The new bridge was designed with 4 longitudinal weathering steel beams. The beams were prefabricated in modular pairs at Wheeler and shipped to the site for quick erection. Simple bolted diaphragms connected the beam pairs after they were set on the abutments. The concrete deck was cast in place and a crash-tested prefabricated steel railing finished the bridge. This video shows the erection of those modular steel units.
While it was on here unstrapping, we made sure our abutments were cleaned off, ready to go. We had laid them out to make sure that we knew where the beams were gonna sit. Picked it off, set it down on the ground to get our safety horizontal lifeline on there so we wouldn't have to get out on the beam. We got that in place, picked it up, swung it over. We set it into place where the beams were supposed to be. And we'll start getting these diaphragms. There's 4 diaphragm beams that we need to bolt onto the first sets of beams. We'll get those bolted into place. Then we will pick up the second set of beams and move it over towards the first set of beams to line up with those diaphragms. We'll set it down, mark the anchor holes on this one, then pick it back up, drill those sets of holes, clean those out, and then set it back into place and bolt the diaphragm beams up to the new section of beams.
According to the project engineer, we specified prefabricated steel on this project for several reasons. One reason was that steel beams are typically shallower than prefabricated pre-stressed concrete systems, which allowed us to keep a low bridge profile height. The second factor was cost. The prefabricated steel beams were less expensive than comparable prefabricated concrete systems. This was a larger traditional type rolled beam bridge that was modularized in the design, planning, and erection techniques to meet an accelerated bridge construction need. So, to summarize, we know that bridge designers, fabricators, erectors, and contractors have always been innovative in delivering bridge projects for owners. Bridge manufacturing firms can deliver high-quality, beautiful bridges that are economical due to economies of scale and efficient, repeated fabrication practices. Most of the prefabricated bridges from manufacturers are also very effective for accelerated bridge construction. Owners and design engineers can find more information on these manufacturer prefabricated bridges and more bridge examples on the Short Span Steel Bridge website, shortspansteelbridges.org. If you need a bridge, these firms can design, fabricate, and deliver a bridge that meets your needs. So, congratulations, we have completed the 6 lectures in the Steel Bridges from Concept to Delivery education packet. We have learned much about the steel bridge industry. We have covered such topics as how steel is made and what types of steel are used for bridges, economics and benefits of steel bridges, the Short Span Steel Bridge Alliance and the National Steel Bridge Alliance that support the steel bridge industry, the design tool eSpan 140 for short span, simple span bridges, how to lay out and detail steel bridges for practicality and economy, and the powerful design software package, Simon. We learned about durability and corrosion protection for steel bridges, how a plate girder is fabricated in the shop, the importance of accelerated bridge construction, and steel bridge solutions for ABC. And right here, options from bridge manufacturing firms for prefabricated steel bridges. I thank you for attending each day and attending these 6 lectures in the series. And of course, if you would like more information about the Short Span Steel Bridge Alliance or on the topics in this series, you are encouraged to visit the shortspansteelbridges.org website or to contact the Alliance directly.